So this is a pretty short unit, a chapter. We're going to be done this on Monday. So Tuesday we'll do some review. We'll do some in-class review and you'll have an assignment to work on. And then Wednesday will be your test on slope. Okay? So, continuing looking at slope, working with slope and percent grade. Yannick and Emily plan to build a wheelchair ramp for their grandmother. They learn that outdoor ramps must have a slope close to 1 to 12, but not greater. This ensures that the person in the wheelchair can safely travel up and down the ramp. So what that means, 1 to 12, means the 1 first, 12 second. It means the 1 on top, the 12 on the bottom. So that is the maximum slope of the ramp. It could be less than that, but it can't be more than that. It can't be steeper. So to start, they measure the space they have to build the ramp. The distance from the doorway straight down to the ground is 2 feet. So that is the rise. The rise is the vertical distance from the top to the bottom. So that's what the 2 feet is. The rise is 2 feet. The walkway along the ground is 40 feet. Well, that would be the run. The run is the horizontal distance. Do Emily and Yannick have enough space for a ramp that meets the safety rule? So we're going to find the slope of this ramp and make sure that it is equal to or less than 1/12. So what we might want to do is take our calculator and find out what 1 over 12 is as a decimal, and it's 0.083 repeating. So our slope, or the slope of the area that they have to work on, cannot be greater than that. So let's calculate the slope for the area they have to work with. Remember, slope, which we use m to represent, is rise over run. We said the rise is 2 feet and the run is 40 feet. A quick check, remember that the rise and run have to be in the same unit, and they are. We saw some yesterday where they weren't in the same unit, and so we had to convert them. But these are both in feet, so we don't have to do any conversions. So now back to our calculator. If you go 2 divided by 40, that's 0.05. Exactly. Now, if we compare that to the safety number, so we've got the same number in front of the decimal, 0 and 0. So those numbers are the same. We've got the same number after the decimal directly. Those are also zeros. When we compare the next number, which is an 8, compared to our number, which is a 5, our number for the actual distance and room that they have is less than the 8. If they build this ramp 2 feet high and 40 feet long, its slope is less than the standard that it needs to be. So they do have enough room. If the slope for the room that they have was greater than 0.083 repeating, then they wouldn't have enough room. They'd have to do something in order to make it work. So they have enough room in order to make it work. But it doesn't mean they have to use the entire 40 feet. It could be less than 40 feet. As long as the slope is equal to or less than 0.083 repeating, then it is safe. So what part B is asking, how long is the ramp in feet to 2 decimal places? So that's asking how long would the ramp be if the slope is exactly 0.083 repeating feet. So again, we know that m The slope is rise over run. That's the formula that we've been using all along. Now we're going to say, what if the slope is exactly 0.083 repeating? The rise is 2 feet. We wanted to know what the run would be in feet. So again, it's going to be something less than 40 feet. If they don't want to use the entire 40 feet along the walkway, how long could that run be so that the slope is exactly 0.083 repeating? So, like we did before, we're going to make both sides a fraction by putting a 1 under the 0.083 repeating. You don't have this booklet? It's in the bottom shelf of the metal organizer there. And the reason we do that is because we've seen if two fractions are equal to each other, their cross products are equal. So we're going to cross multiply. And I'm going to start with the pair that has the x in it. So it'll be 0.083 repeating times x equals 1 times 2, which obviously on the right side, 1 times 2 is 2. Or 2 feet. Some of the examples we had before, when we cross multiplied, we had the variable by itself. In this case, we don't. We've got to do one more step to get x by itself. So these two numbers, or the number and the x, are hooked together by multiplication. The opposite of multiplying is dividing. So we're going to divide both sides by 0.083 repeating to get the x by itself on the left. When you divide something by itself, they cancel. So you're going to get 1x, or just x, equals. And on the right side, I need to do that division. I need to divide 2 by, and you want to use the entire decimal, 0.08, and I'm going to fill up my screen with 3's. I didn't save it into my memory slot, so I need to do it this way. 2 divided by that decimal. The more decimals you use, the more accurate your answer is, and it's actually going to be exactly 24 feet. We don't have to round it at all. Let me just check that number. Yeah. So they didn't need to use the entire 40 feet. They can only make that ramp 24 feet long, and it'll still have the proper slope. And again, it could be less than that. The slope could be less than that. But if you want it to be exactly meeting safety standards, that's how long the ramp would be. So slope is used in order to determine how safe something is. This next example, we're looking at the safety of a slide. A local playground has a slide that reaches 200 centimeters along the ground. The top of the slide is 120 centimeters above the ground. So you can see on the diagram, the triangle is kind of drawn there. Safety rules state that the slope of the slide cannot exceed, which means it can't be greater than 0.577. Does this slide comply with the rule? So we want to find the slope of the slide. And again, M, the slope is the rise over the run. The rise is the height. You think about it, rise means going up or down. It's the height, which in this case is 120 centimeters. The run is the horizontal distance, the distance along the ground, which in this case is 200 centimeters. So we'll use our calculator to find out what this is as a decimal. 120 divided by 200 is 0.6. And remember, when you find slope, There's no units to it. When you divide 120 centimeter by 200 centimeters, the centimeters cancel. You just have the number. Now, if we compare it to the number that we're given, they both have a 0 in front of the decimal, so those two numbers are the same. But when we look at the number after the decimal, in order to be safe, that number cannot be greater than a 5, but this number is. 0.6 is greater than 0.577. So therefore, this slide does not comply with the rule. The slope of the slide is greater than what the safety standards say it should be. So we can say the slide does not comply with the rule. Okay, it's too steep compared to what it should be. Example 2. Tanya works for the Department of Transportation. Her job is to place warning signs in areas along the highway that may be dangerous. So basically, it's a warning to tell vehicles that the hill is steep. This is especially important for truckers, guys that drive big trucks. If they're coming up to a steep hill, they'll often pull over. There'll be a spot for them to pull over, and they check to make sure their brakes are working properly. In the wintertime, they may put chains on their tires to give them traction to go up the hill or to go down and being able to brake if they need to. So what is the purpose of this road sign? It's to warn travelers that there is a steep hill ahead. That's what the purpose is. To warn travelers that there is a steep hill ahead. Now we can see that this sign says that the grade is 8%. And part B says, what does 8% grade mean? Express the slope of the road as a fraction. Well, remember, we've worked with percent before. Percent means a number out of 100. So 8% means 8 out of 100. And remember that if we're talking about slope, slope is rise over run. So that's what this means. It means that for every 100 meters traveling forward, the road is going to drop 8 meters. That's what it means. Remember, a percent means a number out of 100, so 8% is 8 out of 100. And if we apply this to slope, which is rise over run, this means that, again, for every 100 meters forward, the road drops 8 meters. That's what it means. Part C says that Tanya inspects a section of the Trans-Canada Highway. She calculates that the road drops 5 meters for every 40 meters horizontal distance. What is the slope? Well, again, the slope, M, is rise over run. The rise part is the up and down. We're told that it drops 5 meters. That's the down. For every 40 meters going forward. So 5 meters divided by 40 meters. Now we could reduce that. 5 over 40, you can divide top and bottom by 5 and get 1 out of 8. So that's the slope of that road. And if we write it as a grade, a percent, then we would just divide 1 by 8. So 1 divided by 8 is 0.125. And if you want to write it as a percent, you'd multiply by 100. So to write it as a percent, you'd multiply by 100%. So times by 100. And the grade of that road would be 12.5%. So this means that the grade of the road is 12.5%. When it asks you to explain what it means, if you look at the sign above, it says 8% grade. So when you get the slope as a percent, you're getting the grade of the road. Which means that for every 100 meters going forward, the road will drop 12.5 meters. Okay? Because percent means a number out of 100. So for every 100 meters forward, the road drops 12.5 meters. And that is the same ratio as 1 over 8. It's the same ratio of 5 over 40. Okay? If we take 5 over 40, it's going to give us the same decimal if we take 1 over 8 or 12.5 over 100. It's the same ratio. They're all 0.125. It's just a different way of expressing it. We were basically given that the rise was 5, the run was 40. We reduced that to 1 over 8. We wrote it as a decimal. We converted it to a percent. And then we said that that percent represents the grade. And then we just defined it in a slightly different way. But it's the same ratio. 5 over 40 gives you the same decimal as 1 over 8, gives you the same decimal as 12.5 over 100. Warning signs are usually placed in areas where the grade is 6% or greater. So should Tanya install a warning sign along the section of the highway from that last part? And the answer is yes, because we found the grade to be 12.5%. That's much higher than 6%. So we've already kind of answered the last part. If so, what grade should the sign show? Well, we've already figured out that the grade is 12.5%. And that is greater than 6%. So yes, she should put a warning sign there because the grade is 12.5%. So the your turn says, you've got that sign there. That means that the grade is 18%. Express the slope as a fraction. Well, again, 18% means 18 out of 100. Percent means a number out of 100. Now that could be reduced by dividing top and bottom by 9, and we'll get 2 over 50. It's the same value as 18 over 100 in both cases. Actually, we can do one more. We can divide top and bottom by 2 and get 1 out of 25. No, that's not right. I'm sorry. I divided by 9. I divided by 2 at the start. So it is 9 out of 50. I divided top and bottom by 2. So those two fractions would have the same value, 0.18. Explain what 18% means. Well, it means that for every 100 meters forward, because it's 18 out of 100, so for every 100 meters forward, the road drops 18 meters. That's what it means. You with us, Tegan? So then it says that warning signs are usually placed once again when the grade is 6% or greater. If a road drops 5 feet for every 90 feet of horizontal distance, would you expect to see a warning sign there? So if we want to find the slope of this line, which is rise over run, it says that it drops 5 feet, so that's the rise. It's going down 5 feet for every 90 feet of horizontal distance. We can use our calculator to find out what that is equal to. 5 divided by 90 is 0.05 repeating. And if I multiply it by 100% to change it to a percent, so now I times that by 100, it's 5.5 repeating percent, or approximately 5.6%. So approximately 5.6%, which if you compare it to the 6%, it's less than the 6% that you need in order to have a sign. Yes? So the reason it does that is because the calculator has only room for so many digits, so it rounds off the last one. So that's why that 6 is there, because it rounded off the last 5 to a 6, because the digit after the last 5 is also a 5. So in this case here, no warning sign is required. Because the grade is less than 6%. The grade of the road is less than 6%. So no warning sign is required. Okay, so that's it for this lesson. So again, Monday we'll finish off this chapter. Tuesday we'll do some review together, plus you'll have a review assignment to work on for marks. Wednesday will be your test on slope. The assignment that I'm going to hand out right now will be due for marks. So you've got to hand it in because it's counting for marks.